presentation.
Hi everyone, I'm Wei Kiong, and my group members are Aida, Badro, Aina, and Yap King. For introduction, GCPV is a system that comprises of PV module, inverter, and components that are connected to a utility grid. In 2011, feed-in tariff mechanism is introduced by the government to attract people to install PV system. NEM, net energy metering, is introduced in 2016 to replace the feed mechanism. It is then revised in 2019 to reduce the net present cost and allow consumers to export electricity with one-to-one offset. For the function of GCPV consists of GCPV systems are configured for utilities and consumers to work on the basis of such advantages in combination with other DER and the power grid. In easy words, to put them in simple words, GCPV consists of solar PV, inverter, meter, and they are connected to the grid. And when the electricity is used or consumed by us, the meter moves in forward, and when the GCPV generates electricity, the meter moves backwards. The advantages of GCPV is that the system provides by some system operators such as NEM and feed-in tariff will offset electricity consumption costs for consumers. As GCPV does not need battery system, it is simple to build. GCPV system has the benefit of efficient energy usage as it does not contain battery, and then it does not have power loss. The disadvantages for GCPV is that it causes voltage regulation problems. The conventional grid works under premise that flow is one way, but the voltage raised by energy pumped into the grid can be pushed levels beyond the appropriate bandwidth. GCPV is able to compromise the quality of electric. PV's sporadic nature means rapid voltage shifts, and this does not mean that voltage regulator because regular changes but can also result in a flicker of voltage. Connection to the grid poses many challenges associated with security. Too high level of grid-connected PV result in problems such as relay, desensitization, nuisance tripping, interference with automatic recloser, and ferrosonance in addition to islanding as described above. Next, I would like to invite Aina to continue the presentation.
Hello.
Hello.
Okay. Hi everyone. I would like to continue this presentation. Okay. Principle used in solar GCPV. The solar panels used to convert light from sun into electricity that can be used to power electrical loads. Then it will flow to the inverter, and from the battery bank, the power is drawn to inverter 2, which converts the DC current into AC current that can be used for non-DC appliances. Then when the solar energy system produces more electricity or excess electricity than it's needed, it is automatically sent to the utility company or the grid. Okay, next. So this is how the solar panel works based on photovoltaic effect. First, the light energy takes to the form of photons, which is the particle of light, And the each solar panel is a sandwich with one side is silicon and is tainted with other metals to make it negatively charged, and the other side will be positively charged. When the photons hit the cell, they will excite some electrons which break loose from atoms. Then they will attach to, and it forms electricity. Okay, next. Okay, this is the challenges in developing solar GCPV. The first is associated with pollution. Although it is less compared to the other sources of energy, the transportation, manufacturing, and installation is associated with the emission of greenhouse gases. The second one is controllability over generating power is limited. Um, it is mean that the voltage rise, voltage fluctuation or voltage imbalance are major problems, especially if small-scale rooftop configurations connected to the low voltage distribution network. The third one is output power fluctuates due to irradiance variation caused by passing clouds. It means that high penetration level of GCPV also causes new problems in the operation of power system. And it is extremely intermittent and available only during daytime. However, it will fluctuate due to the clouds. The fourth is low in project financing by private and public sector. Um, the low in financing makes it harder to develop a large-scale design, which clearly needs large investment. And the last one is the technical problem that happens in Malaysia, which is inverter shutdown or damage. Other problems such as inappropriate sizing between inverter and pivot array. Okay, that's all for me. I will pass to the next presenter.
Good morning.
Good morning.
Okay. I would like to present utilization and performance of GCPV in Malaysia. So there is three types. The most popular one in GCPV using Malaysian climate, which is polycrystalline, amorphous, and monocrystalline. So to calculate the utilization of GCPV is base performance ratio, which is binary is annual, monthly, or daily net energy output divided by the reference yield. As you can see from the graph, mostly from 2008 to 2011, the most performance, which is amorphous silicon. So the annual performance ratio value of amorphous silicon photovoltaics were higher than polycrystalline and monocrystalline because they have temperature dependence, and the optimum temperature is 24.9 Celsius up to 35 Celsius. They also have low irradiance behavior and the metal stability nature in electrical properties of GCPV performance. So amorphous silicon PV is suitable under tropical conditions such as Malaysia. And in order to design and utilize the performance of GCPV is select the optimal sizing ratio of the grid length, reduce band gap on amorphous silicon photovoltaic, which leads to increment the current, and the prevent cell overheating by the implement bypass diode. Next, I would like to give to next presenter.
Good morning. I'm Yap Yip King, and I'll now present about the cost transaction based on the countries over the years in Europe. As you can see from the slide, crystalline Europe has the highest bound from 2009 until 2014, where thin film A silicon has the lowest. Next slide. From this slide, I'll be presenting about the procedure for the testing and commission of grid connection photovoltaic system in Malaysia. Firstly, this testing and commission procedure is only applicable to quota offered from 2014 onwards. The inverter side test is required for all PV system connected at medium voltage. The commission test for installation is up to 12 kilowatts to be carried out by the owner qualification person without the presence of SDE Malaysia representative. The fee for TNC witness for solar PV under 2015 community categorized is example with the effect from 15 October 2015. The commission test for installation greater than 12 kilowatt must be carried out by the representative qualification person in the presence of SDE DA Malaysia representative who will sign off the commission checklist. This checklist is request to be submitted to TNB when applying for testing and commissioning of the grid interconnection. The table below shows the categorized and fees to be paid to SDE Malaysia when you install the photovoltaic system. That's all from me. I'll pass on to the next presenter.
As a conclusion, it is advisable to install GCPV system as the policy promoted by Malaysia government is really attractive, but on the condition that your family can afford it. We will be saving on electricity bill from day one when we install GCPV system. This could translate into a return of initial investment of 15 to 30% per annum, as long as the GCPV system does not spoil. Electricity generated from GCPV means that our house will draw less power from the grid, and this will help to reduce the carbon footprint. Thank you.